Good day guys, so today I'm going to show you how to sketch a curve. So we are given the function y is equal to x cubed plus 3x squared minus 4. In sketching a curve, we must use the first derivative test. So the first step is to derive the given function. So now we may be able to get our y prime is equal to 3x squared plus 6x. The next step is to equate the derived function into 0 so that we may be able to get the x of our critical points. Now, as we equate x to 0, it resulted to 0. 3x plus 6 is equal to 0 results to negative 2. Why? Because as we equate 3x plus 6 equal to 0, it will result to 3x is equal to negative 6. And we must divide everything by 3 in order to get x. So negative 6 divided by 3 result to negative 2. Now, to complete our critical points, we must substitute these two x's to the original function. Now, as we substitute 0 to the given function, it resulted to negative 4. Next, as we substitute negative 2 to the original function, it resulted to 0. Now, we have our critical points 0, negative 4, and negative 2, 0. So the next thing is we use this line graph so that we may be able to know if the curve is increasing or decreasing. Now I plot the 0, the axis, the 0 and negative 2 so that we may be able to get the intervals from them. So we are going to use x that is less than negative 2, x that is greater than negative 2 and less than 0, and x that is greater than 0. So as you can see, there are positive, negative, and positive signs here, so I'm going to explain later why did I write it there. So x is less than negative 2, we use the value negative 3 since it is smaller than negative 2. Now, in order to know if our curve is decreasing or increasing, we must substitute this given x to our y prime, which is 3x squared plus 6x. Now, it resulted to 9. So, since it is a positive number, therefore, it is increasing. Next is at x is greater than negative 2 and less than 0. So it is from here to here. So the number in between that we use is negative 1. So as we substitute it to the derived function, it resulted to negative 3. So therefore, the curve is decreasing. Next, at x is greater than 0, we use x is equal to 1. So as we substitute it to the derived function, it resulted to positive 9. So it is increasing. So now we can say that at x is equal to negative 2, see the one that we use, the intervals less than negative 2 and x is greater than negative 2, the curve is from positive to negative. So therefore, our critical points from this one, 0 and negative 4, is a local minima. And from this point, negative 2 and 0 are critical points. Our critical point is a local maxima. So in order to get the last step, which is the x and y intercept, we must equate x to 0. So the given function is x cubed plus 3x squared minus 4. So we just have to substitute 0 to x. Now our y-intercept is equal to negative 4. And in order to get the x-intercept, we must equate y to 0. So this is our given function. We equate y to 0. And our roots, the roots of this function is x minus 1 and x plus 2 squared. So now we already know that the x-intercept is 1 and negative 2.